In this short video, I'm going to show you how to use Industrial HiVision to achieve three things related to power over Ethernet. The first is to obtain a comprehensive overview of the PoE functionality on your network. The second is to configure PoE functionality on your network. The third is to optimize the utilization of available power in order to support the maximum number of devices. Okay, let's get started. In this small network, I have three switches, one of which is capable of providing power over Ethernet. In this case, it's the RSPE switch at the top of the diagram. As you can see, there are two wireless access points attached to this switch, and there is also a sensor attached to the switch. All three of these devices are being powered via the RSP with power over Ethernet. Let's take a look at how that looks in the overview. On the left of this screen, you can see PoE information about the RSPE chassis overall. So we can see, for example, how much power could be provided by the switch, how much is reserved, how much is remaining, and so on. If I move the screen to the right, you can see the same information, but this time for the PoE module, which is in the RSPE switch. Clearly, if I had more than one PoE module, then I would see both modules listed here. The same is true if I had more than one PoE switch. I would see the same information for all PoE switches on the network. Now let's look at port level. I select the port option from the drop-down box. Now I can see the status of every PoE port on the network, even if it is not currently delivering power. So you see here some statistical information. Moving to the right, I can see which ports are actually delivering power. I can see their class. I can see whether they are checking for class 0. I can see which classes would be accepted. I can see power consumption, maximum power consumption. And of course, I can see when PoE would be enabled or disabled on a daily basis. Now I can show you how you could configure PoE functions on all PoE ports across the network at the same time. First, we'll select the ports. In this case, we select all ports, whether they are in use or not. Then we'll go down to the multi-config menu. So here you can see PoE. The information is being read back from the devices. Let's be a little bit patient until they're completely read. Okay, there we go. Now you can see where I can enable or disable PoE. I can enable fast startup, which means the device will start delivering PoE even before it's fully booted. I can change the PoE priority. I can decide which classes are available. Then I can also decide if I want to use auto shutdown. What this means is I could disable PoE at the end of a working day, for example, to shut down the wireless access points, and I could automatically enable it at the beginning of the next working day to bring the wireless access points up again. So all I would need to do to change any of those parameters is select them and click Write. Now let's go back to the main screen and take a closer look at how we're using our power. What you can see is that the switch itself has a budget of 120 watts. In other words, it will support 120 watts. Of those 120, 85 are remaining. This is because 35 have been reserved. But look closely. How many watts are actually being delivered by the switch? Only 10. Nevertheless, 35 watts have been reserved. This means that 25 watts are actually wasted. They are available, but they cannot be assigned to an end device. Keep in mind the figures. 35 watts reserved, 85 watts remaining. Now we'll go back to device level and look in more detail at what is actually causing this problem. First of all, let's hide some columns to make the screen a bit clearer. Okay, that's better. Now we can see that there are 3 ports on the switch which are delivering power. These are ports 5, 6 and 8. Now we can see ports 5 and 6 have detected a class 3 device. So those 2 devices are in fact the wireless access points. Port 8 has detected a class 1 device. This is the sensor. For a class 3 device, the power source equipment, in other words the switch, will reserve 15.4 watts per device. For a class 1, the switch will reserve 4 watts per device. So in fact we've got a consumption of 2 times 15.4 watts plus 1 watt. That is where the 35 watts reserved power comes from. Now let's move along the screen a little bit and look at the actual consumed power. So for the first wireless access point, the maximum consumed power has been 4.3 watts. For the second access point, the maximum consumed power has been 5.6, and for the sensor we have a maximum consumed power of 1.6. In total, that means we have a total consumed power of 11.5 watts. Now compare that with the reserved 35 watts. Clearly, this could be optimized. Now I'll show you how to optimize the power consumption. First, select all the ports. Now I'm doing this with one single switch, but it would work with multiple switches simultaneously. So I've selected the ports, I right-click and I take Multi-Config. And what you can see at the top here is the Automate Power Limit menu, so I'll select that. Okay, now HiVision is reading the maximum power consumption from the devices. Okay, that's done. So let's tick the Automate Power Limit box. And now you can see a percentage has appeared. That percentage is used to calculate how much power should actually be assigned to the device. And the percentage is the percentage on top of the maximum ever consumed by the device. So once that option is selected, let's go to the bottom and click Write. Now you can see that the values are being calculated and they're being written to the devices. Okay, that was fast. Now they are done. Let's close Multi-Config. Let's head back to the device menu. I'm sure you remember the figures from before. Remaining was 85 watts and reserved was 35 watts. As you can see, the figures have not changed. That's because we need to reload the entry. So highlight it, click Reload. Let's be a little bit patient. Okay, so now look at the figures. Remaining 107, reserved 13. So what we've achieved is to claw back 22 watts, which we can now use for other devices. So clearly we've greatly optimized the way that power is used across this network. Okay, that's what I wanted to show you. I hope you found it interesting. Thank you for watching.